Hello and welcome to the 9th and penultimate video in the not-so-mini video series on Linux Essentials. In this video series, as I'm sure you know by now, I'm running through the top things I believe you should really know when using the Linux CLI, focusing on just core, essential knowledge that will get you by as a daily Linux user. I put this course together to help some of my users who were struggling with the Linux CLI when attempting to follow my video series on hosting a website and an email server. So I'm hoping for those users you found it useful so far. And you're nearly there. This is the penultimate video. So in this video, we'll be looking at how to find out how much storage space you have available on your system from the CLI, how to very quickly free up space if you're running out, and then we'll take a look at how we can go about finding out what on your system is using up most of your storage. A very useful thing to do if you find that you're running out of space. Okay, great, that's what's on the menu. Let's now then head over to my desktop and get started. But as always, before I do, I just want to raise to your attention my Patreon account. If you're interested in accessing videos that aren't available on YouTube, would like one-to-one support, or would just like to support my work, please do visit my Patreon account. Thank you. Okay, so here we are on my desktop, ready to go in my bash terminal, in my user Pi's home directory. So as normal, I'm using a Raspberry Pi as my Linux operating system, but you don't have to. So firstly, let's take a look at how much storage space is available on my system in general. This is a very easy thing to do and is a command that you'll be able to very easily remember. And it's something you should do quite regularly. You do the following: df space -h. The -h option is to provide human readable units for the file sizes. So we can see, for example, in this case, we've got gigabytes, megabytes. There is no K for kilobytes, but that's what you would have. Oh, here's one, K for kilobytes. So human readable makes it a lot easier to digest the numbers. But otherwise the command is just df. The df command shows us all of the available file systems, and you'll certainly have more than one listed. In my case, as you can see, I've got many listed. The one of main interest is going to be the one that is mounted at the root of your operating system. This one here. So for me, it's dev/root is my main system. So this tells me basically how much storage I have to play with. In my case, I have 46 gigabytes of storage available still, of a total 60 gigabytes, which means I've used 20% of my available storage. So remember df-h to check what your available storage is. Now, as this is an Essentials course, I won't go through all of the file systems listed here. However, I will mention the tmpfs file system because it's coming up many times on my Raspberry Pi and I feel it justifies an explanation. So tmpfs stands for Temporary File Storage, and it is a file store which appears as a mounted file system, as you can see, but is actually located in volatile memory, i.e. RAM. It's temporary because if you restart your system, everything in those tmpfs file systems will be lost. If you see these on your system, it's very likely you didn't create them directly, but some other process on your system has. So just to be clear and to reiterate, these file systems, tmpfs, are stored in RAM, and they are there to appear as mounted volumes, often for the benefit that the file stored in RAM is made available to multiple processes. So no hard drive space is being taken up with all of these. Well, apart from boot. But all of these are temporary file systems. Incidentally, these are also often known as RAM drives because they're mounted drives on the file system, but they're stored in RAM. Okay, Enough of that tangent then, let's get back to the core of this video. So assume now that we've looked at our storage, as we just have, and found that we're running short. How can we free up some space? Well, there's actually a really easy way to free up some space without having to go searching through your drive. It goes as follows. It won't hurt for you to do this, so you can do as I do. Sudo apt-get clean. Press enter, followed by sudo apt-get auto-clean. It's going to clean up any packages we no longer need, and then sudo apt-get auto-remove. And it's going to free up some disk space for me. So I'll say yes please, and let it do that. Okay, clear my screen. Okay, if you want to go further, you can also remove old kernels which have been left behind on the system after an upgrade. But I'll leave that one for you to Google, as it's something which requires some care and is a little bit beyond an essentials course, but it's worth knowing. So after you've done what I've just done as a means of clearing out unwanted content on your system, it is worth having a look at how you can delete old kernels as well. Okay, so say you've done the above, but found that you still haven't got enough storage space left. Well, hopefully you know where you have put a lot of your content, and you can quickly find it and delete it. As a guide, most of the content you have personally added is very likely to be in your home directory, which would be a sensible place to look first. But suppose you are administering a system for multiple users and wish to find out who is using the most storage quickly. Or suppose you would like to find out which of your many directories of content is the largest so that you know where to look first to delete content. Well, there is a useful tool you can use to help you do this. In fact, there are two good approaches which we'll cover. The first one goes as follows. The syntax is du followed by the folder name -hs. So let's say I know a project I created is pretty large and I want to see how large. Well, I can do so as follows. So I'm going to just replace folder name. Sorry, I misspelled folder name. It should have been folder name. I used an I instead of an O. So let's look in my home Pi website directory. Okay, so what we can see here is that my website directory is 112 kilobytes big. So in this contrived example, it's not actually large, but let's assume it is. Suppose now I want to know what is causing that usage within this large directory. Well, we can go down one level and find out as follows. I'm going to use the up arrow on my keyboard. I'm going to go back to here. I'm going to type in / and I'm going to use an asterisk to search through that directory. I'm going to press enter. So here I've just added the asterisk at the end of the command, and the output shows us the file and folder sizes within the website directory, which are making up the directory size we just saw. Now, for those eagle-eyed viewers, you may notice that the numbers don't exactly match, because the directory itself has a certain amount of size. So the directory content, 112 kilobytes, will be slightly larger than the sum of the content inside. In fact, in this case, I believe it's probably 4 kilobytes larger. So that's normal. Okay, so this is useful, and I'm sure you can see how useful this is going to be to you already. But we're still going to have to dig around inside, for example, in this case, the Nginx folder here, to find out what's using the most storage inside. It's helpful, but it's not ideal. So there is one more thing we can do to help, and that is to use the -a option for du, which means all. So with -a included, du will crawl through the directory tree and come back with a list of files and folder sizes for all files and folders below the directory it is pointed to. Now, though that sounds great, unfortunately, du won't order the list by size, which would have been convenient, as we're likely only interested in the big files. So we have to construct, using pipes, a slightly convoluted command to get the output in size order. It goes as follows. What I'm going to do is just copy and paste it from my notes, but I won't press enter yet. Oops, that's not right, excuse me. Try again. There we go. Okay, so here we can see we're first elevating our permissions with sudo, just to make sure we have sufficient permissions to crawl the directory. Better safe than sorry, basically. We're then using du with the aforementioned -a option for all. We're then defining a block size in kilobytes so that the size units coming back are in kilobytes, which makes it easier for us to interpret. Incidentally, we could have used G for gigabyte or M for megabyte, whatever you prefer, but kilobyte suits this case very nicely. We then define the directory here that we wish to crawl. In my case, it's my website directory, followed by a couple of pipes, which will order the list in size order and then restrict us to just the top 5 results. Okay, there we go. So with this command, we can see which files or directories are the most responsible for the use of storage within the directory specified. The pipes following the du command sorts the output from du from largest to smallest and shows the top 5 results only, as I've mentioned. So you can now imagine how useful this could be in finding where most of your storage is, particularly in your home directory, for example. You can change the number of returned lines by adjusting the 5 here. Kind of makes sense. So if I do that and go 8, I get more results. But 5 is a very convenient number, so I'll keep it there. Okay, so thus far we've shown 3 useful uses of the du command. We've looked at finding a directory's size in the first place, finding the size of the content of that directory one level below, and then finding the size of all objects inside a directory ordered from largest to smallest. All 3 of these are explained because du is readily available with your distribution, and each of these examples have their own use cases. You can imagine running these commands on your home directory, though be warned, the -a option may take a while if it's a very large file system to be crawled. Okay, so that's it for the du command. There is another tool we can install and use, which does a similar job. It actually uses du behind the scenes. Let's have a quick look. It's called Ncdu and may be available already to you, but just in case, let's install it as follows. Sudo apt-get install Ncdu. As you can see, I already have it, and you likely will as well, but just in case, run that command. So what Ncdu does is it provides you with an interactive version of du that enables you to click through your directory tree and see what is using the most space. It's a very nice tool and works as follows. Let's give it a go. Ncdu/home/James, oh, not James, that would be on my main computer, /pi /website. Okay, so you can see it's occupied my entire screen. That's because it's a graphical interface in the terminal. It tells us at the bottom that the total usage for the directory we're pointing at is 112 kilobytes. Okay, and it tells us in total there are 9 items. So this alone is useful. It tells you how many directories and files there are inside the directory we're pointing at, and it tells us the total disk usage. So very useful indeed. What we've got here is the size of the files or folders here, and the files or folders here. And in the middle there's a bar, and the bar is telling us the fraction of this directory level being used up by the files and folders. Now, because Nginx is a folder and contains the largest file, it contains 92 kilobytes, the bar is full for Nginx, but you can imagine in more complex directory structures, you would be able to at a glance see what is using up more space. I can use the keyboard up and down arrows to move left and right, and I can move up and down, and I can use the right and left arrows to go into and out of a directory. So I press the right arrow to go into the Nginx directory, and in here I can see what's using up most of the space. 76 kilobytes, for example, is being used up by the Let's Encrypt zip file. Okay, I can go up and down if I wish, and I can go back. So that's how it works. You can imagine how useful that will be for complicated file systems. So a fantastic utility to keep in your mind at all times. Okay, Control-C to back out. So as you can see, both approaches I've demonstrated, DU and Ncdu, are highly useful for profiling your drive and understanding where your storage is located. I hope you found this useful. It's a bit of a shorter video, thankfully, and it's also the last but one. If you have, please do like the video and please do subscribe to my video series. It's the best way of showing appreciation, and also if you'd like to, please do check out my Patreon account if you'd like to support me or if you'd like one-to-one support. Okay, thank you very much, and I'll see you in the next and final video of my Linux Essentials course.